In this video, we're going to take a look at the periodic table, specifically taking a look at how the periodic table is arranged. To begin with, what is the periodic table? The periodic table is a simple organization of all of the known elements. So all of the different types of atoms, all the different types of elements, we have organized those into a table based upon their properties, based upon the number of shells they have, based upon the number of valence electrons that they have, based upon whether they're metals or nonmetals. So we can take into consideration all these different characteristics, and we can place an element in a specific spot in the periodic table based upon those characteristics. So who created the periodic table? The person that first came up with the periodic table was a Russian chemist named Dmitry Mendeleev. Okay, Dmitry Mendeleev. He lived quite a few years ago, but back in his time, around 1860, there were 60 known elements at that time. Right now, we have upwards of 118 known elements. So about half of the elements men have discovered at this point in time. So he knew of about half these elements, and he knew that these elements had particular properties, specifically the property of atomic weight. He arranged the elements into a table based upon their atomic weights. Now, also when he arranged these elements, he noticed that there were gaps. He noticed that not all of the elements were present. There were holes in his periodic table based upon these weights. So that led him to conclude that there were still some elements out there that had not yet been discovered. So how specifically is the periodic table arranged? The periodic table is, again, arranged based upon elements and the different elements, their characteristics. And it's organized like a big grid. Okay? So we have columns and we have rows, we have periods, and we have groups. And each one of those particular sections corresponds with a particular characteristic of an element. So let's first take a look at periods. So periods are the side to side. Okay, they are the ones that go across. You can see up here we have period number 1, period number 2, period number 3, period number 4, and so forth. So periods go across. Now, even though we have this big space in the middle, each one of these periods means something. So period number 1, for example, that means that those particular elements in that particular period, okay, only have one electron shell. So periods equal rows in the periodic table, again going across. All the elements in a period have the same number of shells. All the elements in the same period have the same number of shells. So if I go back and look at the previous slide, in here I can see that here I have hydrogen and helium. They only have one electron shell because hydrogen only has one electron, and then helium only has 2 electrons. And we know that 2 electrons fit in the first shell, therefore period number 1 only has 1 electron shell. So all of the elements in that period, 1 electron shell. Now in this next period going across, all of those elements have 2 electron shells. Okay, so they've got 2 electrons in the first shell, therefore they have more than 2 electrons. Magnesium, for example, has 3 electrons. It means 2 electrons are going to go in the first shell and then 1 electron in the second shell. So these elements have 2 electron shells. These elements have 3 electron shells. These have 4 electron shells. These have 5 electron shells, and so forth. Okay, so they're all organized based upon their electron shells. Okay, so periods equal rows. Periods go across, and those are the number of electron shells. If you're in that particular period, if you're in period 1, that means you have 1 electron shell. If you're in period 4, that means you have 4 electron shells. Now, another organizational pattern on the periodic table are your groups. Now, groups go up and down. So these are all my groups. They go all up and down here. These are my groups going up and down. Now, groups or columns, we call them groups. Those are organized by the number of valence electrons. They're organized by the number of valence electrons. Okay, so group 1, for example, has 1 electron in its outermost shell. 1 valence electron. Okay, every element in the second column, okay, or group 2 has 2 electrons in its outermost shell, 2 valence electrons, and we can work our way across that as well. So let's go again look again at the previous slide, right here at our groups. So all of these elements right here have 1 valence electron. They have 1 electron in their outermost shell. Group 2, okay, they have 2 electrons, or 2 electrons in their outermost shell. Then we're going to jump over here, okay, and we're going to go to group 3 right here. Group 3 has 3 electrons in its outermost shell. And we can work our way all the way over here, in which we have 8 electrons. Okay, group 8, 8 electrons in its outermost shell. Okay, so those are some basic organizations of the periodic table, some basic trends or some basic groupings that we see in the periodic table. Now, other things you've already noticed in the periodic table, and such as atomic number. So, for example, we read left to right for our atomic number. So, excuse me, hydrogen has 1 for its atomic number. Helium has 2. And then we work our way across. We have 3, okay? Oops, 3 is down here. 4, 5, 6, 7, 8, 9, 10. Go back. 11, 12, 13. And we can count our way across based upon its atomic number. Okay? So we're starting to see different organizations with regards to our periods, and then also our groups, and then also atomic number. Now at this point we're going to stop, but we're going to pick up in the next video with other categories such as our alkali earth metals and our noble gases, and that's going to take into account how they react with other elements. But again, those are in specific spots based upon their characteristics. So you can see that in the entire periodic table is not randomly arranged. It's arranged based upon a number of different patterns that we see, and we can predict and determine the characteristics of each one of these elements based upon these patterns that we see. All right, so if you need to go back and see that and watch this again to kind of get a better grasp on this, please do so, and we'll pick up in the next video and talk about some other patterns and trends in the periodic table.